In this video, we're going to be talking about the definitions of trigonometric functions of any angle. We're also going to be evaluating trigonometric functions. So let's let theta be any angle in standard position with x, y a point at the terminal side of theta and r equaling the square root of x squared plus y squared, which does not equal 0. So what is that saying? Well, what that's saying is that we pretty much create a right triangle here. So we have our radius, which is the distance from the center of our circle, or from our angle point, from our vertex, to our xy. And from there, we're able to create a right triangle with a value of negative x, or rather just an x, y. We're going to talk a little bit more about x, y, or x and y distances in a moment. So again, this is going to be our right angle here, and this is going to be our reference angle. So right now it's just helpful to know that when we have an x, y, we create a right triangle. So in order to find our r, we're simply just finding the hypotenuse of a right triangle. And this equation right here, our r equals the square root of x squared plus y squared, is simply Pythagorean's theorem. So as we look at our sine, cosine, tangent, cosecant, secant, and cotangent, we can put those in terms of x and y. So our sine is going to be the opposite over our hypotenuse, which is r. Our cosine is the adjacent over our hypotenuse. Tangent is the opposite over our adjacent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Let's put this into action. In this example, we're going to let negative 3, 4 be a point on the terminal side of theta, as shown in the figure. We're going to find the sine, cosine, and tangent of theta. Now, in order to do that, we're going to need the hypotenuse value, or our r value. And so we're going to go ahead, and here we're going to have our x and our y. So we'll label those x and y. And we have a right triangle. So we know, based off our equation above, that to find our r value, we simply just need to take our x and square it, and add that to our y quantity squared. Doing that is going to give us an r value of 25. Oh, excuse me, square root of 25. And the square root of 25 is, in fact, 5. So we have an r value of 5. Now we can find our sine, our cosine, and tangent. So here we'll have a sine, or a y value, of 4. And a hypotenuse of 5. Our cosine will be our x, or our negative 3, over our hypotenuse of 5. And our tangent is our opposite, or our y, over our x, which is a negative 3. And now we've found our 3 values of sine theta, cosine theta, and tangent theta. Notice that in this particular example, only the sine value was positive, and that's because it's in the second quadrant. Let's talk a little bit about how we can tell which of our 6 trig functions would be positive and negative. So there's a little saying to help us. All students take calculus. In the first quadrant, all 6 of our trig functions are going to end up being positive, because our sine, our cosine, and our tangent will be positive, because we have a positive x and a positive y. Our r will never be negative because it's a hypotenuse, and so it's a distance, so it will never be negative. The second quadrant represents our s, or our sine function. Notice here that only the sine function is going to be positive, as the y is positive, but the x is negative. In quadrant 3, that's going to be our tangent that's positive, because our y and our x are both negative. And so the only time that those will turn into a positive is when we have a negative divided by a negative, as we do with tangent and cotangent. And lastly, we have quadrant 4, which is cosine. Notice here that our x is positive while our y is negative. So we have all students take calculus. So in the first quadrant, all of our functions are positive. In the second quadrant, only the sine and cosecant are positive. In our third quadrant, our tangent and cotangent are positive. And in our fourth quadrant, cosine and secant are positive. So another thing to look at here is how can we tell and when it's given to us in radians? And so notice that here, when we're in the fourth quadrant, we have 3 pi divided by 2, which is less than theta, which is less than 2 pi. So that would tell us that we're in the third quadrant, or that we're using cosine for our positives. When we have theta is between pi and 3 pi over 2, that puts us in our third quadrant, or our tangent quadrant. When we're told that theta is between pi over 2 and pi, we know we're in our second quadrant for our signs being positive. And when theta is between 0 and pi over 2, we're in our first quadrant where all of our trig functions will in fact be positive. All students take calculus as a very important and a very helpful tool in helping you to be successful when it comes to evaluating trig functions. In this next example, we're given that sine of theta equals negative 2/3 and that the tangent of theta is greater than 0. We're going to be finding the cosine of theta and the cotangent of theta. So with that, we know that we have a y value and an x value, or excuse me, a y value and our r value, but we don't really know which one is, well, we do know which one is the negative because our r, which is our radius, can't be negative, so our y value must be the negative. So we want an x, a y, and an r to be able to find our cosine and our cotangent. Now we are told also that the tangent of theta has to be greater than 0. Now remember that tangent is y over x, and we know that our y value is already a negative. So in order for tangent of theta to be greater than 0 or a positive, that also means that x has to be a negative as well, because a negative divided by a negative creates our positive. So here we have a x value of negative 2 and an r value of 3. What we're missing is our x value. So we're going to use Pythagorean's theorem here. So we have x squared plus negative 2 quantity squared equals 3 squared. So we're going to go ahead and subtract over our 9, our 4, and we have 9 minus 4. So now from there, we're going to take the square root of 5. So that's going to tell us that x can either be a negative square root of 5 or x can equal a positive square root of 5. But we know, because we want our tangent of theta to be positive, that our x needs to be a negative. So we're going to select the negative square root of 5 as our x value. Now that we have that, we can go ahead and we can find our cosine of theta, which is going to be our x over our r, or negative radical 5 over 3. So now we found our cosine of theta. So next we need to find our cotangent of theta. So our cotangent of theta is the reciprocal of the tangent. So our cotangent will be the x over the y. So we'll have negative radical 5 over negative 2, which will reduce to a positive radical 5 over 2. And now we found our cotangent of theta as well. In this next example, we're going to be evaluating the cosine and tangent functions at the angles 0, pi over 2, pi, and 3 pi over 2. So here we want to kind of focus on our unit circle. So here we have our unit circle, and we're going to be going 1 unit away. And so for an angle of 0, we'll be using the point 1, 0. For pi over 2, we'll be using 0, 1. For pi, we'll be using negative 1, 0. And for 3 pi over 2, we'll be using 0, negative 1. Because we're using the unit circle, it also means that we'll have a radius value of 1 for each of our angles. So as we look for the cosine and tangent functions of 0, we'll have an x value of 1, a y value of 0, and an r of 1. So our cosine of 0 is going to be a 1 over 1, because that's x over r, which equals 1. And our tangent of 0 is going to be our y over our x, which is going to give us a 0 over 1, which is 0. To find the cosine and tangent functions of pi over 2, we'll have x equals 0, y equals 1, and r equals 1. So for our cosine of pi over 2, we're going to have our x over our r, or 0 over 1, which is 0. And for our tangent of pi over 2, we'll have y over x, which is 1 over 0, which will be undefined. To find the cosine and the tangent of pi, we'll be using x equals -1, y equals 0, and r equals 1. So our cosine of pi is going to be our x over our r, or -1 over 1, which is -1. And our tangent of pi is going to be y over x, which will be 0 over -1, which is 0. Lastly, to find our cosine and tangent of 3 pi over 2, we're going to be using x equals 0, y equals -1, and r equals 1. So to find the cosine of 3 pi over 2, we're going to take the x over the r, or 0 over 1, which is 0. Then to find the tangent of 3 pi over 2, we're going to take our y over our x, which is -1 over 0, which is undefined. And so that's how to evaluate the cosine and tangent functions at the angles 0, pi over 2, pi, and 3 pi over 2.